I think one thing that I think is interesting with all of this is that you have your chart where you've got the past and the future. And one thing to look at is obviously around the time of the Industrial Revolution, we had a kind of singularity where you have rapid technological progress. You also have new institutions that form in defense of the big corporations that we have now, which are also driving centralization in the economy. Also, governments scaled up very rapidly. If you think of governments, pre-1800s, they obviously operated at, they were much smaller governments. They had less influence on daily life. They operated at a much smaller scale. And it seems like there are two interesting things that come out of that. One is, what are maybe the differences with this potential AGI singularity? Because I think you can think of large governments or large corporations as some form of AI. It's quite artificial. It's definitely not human. And there's some form of intelligence, and there's some decision. Actually, to some extent, governments and corporations still do more decision making than AIs. Where for now, at least with AIs, we're still mostly in charge of decision making. But that might change as we give kind of more and more autonomy and more agentic capabilities to AI. And so I think it's maybe interesting to think of what's different this time. And also to think, I think, because like you said, it's very hard to predict the future. And even if you look at, prediction markets, past, a year, 2 years, the accuracy of predictions tells off, very, very quickly, let alone 100 or 100,000 years. But something that can be instructive, I think, is to also try to imagine, what's the future that we actually want, and try to work backwards and say, let's not try and predict what is going to happen, but let's maybe try to think, what could we do to make what we want to happen, actually happen. And it seems like there's maybe as well looking, what's different now between kind of AGI compared to the Industrial Revolution and big corporations, big governments, and things like this. It seems like maybe there's a bit of interaction between these two questions, which is, what went wrong the first time, and how do we avoid what went wrong?
I think it's great to compare it to the Industrial Revolution. So the main thing that happened in the Industrial Revolution is that it was a revolution of power. I mean, like actual physics-defined power, being able to do manual work at different scales. And so we came up with initially a whole bunch of steam engines that are able to do a range of different types of work. And that led into a whole bunch of other forms of industry and ways of applying that power to do, to mechanize all kinds of stuff. But fundamentally, it kind of replaced the human need to be engaged in applying individual physical labor at scale. Like whenever you hit a certain level of scale, you just kind of apply the steam power thing to it. And you can output a tremendous amounts of force. Now, and so there we were really trying to replace our ability to move stuff. And we effectively did it. We built a technological way of doing that, and that rippled through the entire economy in a bunch of different ways. However, what's qualitatively very different this time is that what we're doing is that we're building an artificial brain. We're building a system that is not exactly replacement, but it's inspired by our organic brain system. And when we look at ourselves and we look at all other living species on this planet, the nervous system in the brain is the most complex and interesting object in the entire planet. And it took a while, it took billions of years to evolve to get to this point. And for the last few tens to hundreds of millions of years has yielded a lot of the big differences that we have been able to see in different types of animals. And certainly in the last million years, it's led to the total rewriting of the story of all living things on the planet. We became this apex predator sort of thing that was able to take on anything and take control of the entire planet in a way that nothing else had been able to before. And so that level of power is similar to the kind of shift that we're about to encounter with artificial neural nets. We are building a brain system, and this one, so the organic one takes a very long time to evolve. We're talking about tens of thousands to millions of years to get significant differences in how our brains are set up. And so the increasing the size of our brain or how it's trained or whatever, it's a very slow process relative to the improvement rate on these artificial systems. To be clear, these things were barely recognizing digits 17, 18 years ago. Now they're composing symphonies and doing a bunch of work and being therapists and being partners. And that's 17 years. Just project that forward. Even if you discount the exponential and just think of a linear improvement rate, we're talking about dramatically more intelligent and much more capable than humans at a bunch of stuff. And I really like the jagged intelligence description that Karpathy has about, kind of, you have a wide range of human capability. These models are like extremely capable in certain things, totally incapable in others, totally incompetent. And so over time, like the jaggedness is kind of growing, but it's really going in one direction. Like it's not like these models are just getting reshuffled. It's just getting improving. And the other piece is that I would say that there's like this interesting, my personal view is that what we'll call AGI in the future kind of has already happened. It's not what everybody's calling AGI today, but I'll give you like a definition. If you think of the distribution of all cognitive tasks, like everything from, like translating a paragraph or adding some numbers together or like solving a puzzle or whatever, like the entire distribution. And then you think of all the distribution of all humans, and then you ask a question of saying, if I randomly sample a cognitive task and I randomly sample a human and I test that human on that cognitive task against the best model, like what is the percentage of like success cases for the model? And I would say that like GPT-3, GPT-4, so probably GPT-4 was kind of like somewhere like a median scale of like being able to beat like the median human at the median number of tasks or something like that. And now GPT-5 is actually closer to 80 to 90%. Like GPT-5 can beat me at like tons of tasks that I've tried. And there are, of course, a range of tasks that I'm way better at still, and certainly the long-running thing and the like deep context and agency and so on. Like these models don't have any of that yet. But in terms of like the raw intelligence and the raw cognitive task capability, they're extremely capable now. And so if you just like project out 2, 5, 10 years, like it just gets very different than what it is now. And again, it doesn't have to be the same architecture. It could be a different architecture. We could hit a slump. It could be a little bit of a bubble. I don't expect it to. But the big thing that I want us to kind of be oriented towards is like the major shift that's coming 10 to 20 years out.
I think one thing I want to pick out actually is you mentioned this kind of analogy with humans are the apex predator and so on. But something I've always disliked about that analogy is that when you think of a predator, and certainly an apex predator, you think of some kind of predator that's hunting some kind of prey. But in many, many ways, a lot of the predatorial things that have happened as a result of humankind have really been externalities. So things like climate change and extinctions of many animal species are not things where anyone really set out to go and hunt them. And actually, if people did set out to go and hunt them in the kind of traditional sense of hunting, they would probably still be alive. Whereas by just having a lot of externalities because we want a lot of cheap plastic-made things, or we want a lot of fossil fuel burned in other ways, has had a much bigger shift than anything intended. And something that's quite interesting is because in some ways, when you look at these AIs, they actually do have quite low agency. That does seem to actually open up the door to a lot of negative externalities which they don't control.
Totally, completely agree. Like I think if we're not careful, we can cause enormous negative externalities, and not just accidental ones, but also willful ones, where not the agents, but humans are going to be using these models for all kinds of like nefarious things, or not even nefarious. Like they might be going for some rational thing that then causes all these externalities that you're talking about, and yeah, it's like this very nasty landscape where you think about all of that possibility and like all of the negative things that will happen, and you're like, oh man, like we just have to get these to be as smart as possible, as quickly as possible. And then you're like, wait, hold on, like then that definitely like cedes control completely, because if they're as smart as possible and like full agency and whatnot, then like, oh man, like that's a totally different landscape. So this is what makes this question extremely hard and makes our challenge as a species so deep, is that it is quite tricky to chart a course through this to like not cause a bunch of damage through these externalities while having this like deep oversight way of training these systems, because you don't want to give a bunch of these things agency ahead of when they're like smart enough to have it. And it's hard to tell when is that smart enough line, and how do you robustly test it, and how do you test what they really are intending to do. This goes into all the alignment questions and whatnot of like, how can you really tell what a model's intention actually is? Like we don't have good, robust ways of doing that. And so yeah, this is like a deep, hard problem. It's just not one that we get to avoid. It's like this is what it's like to be an intelligent species in this universe, and you just kind of go in this trajectory, and you start co-evolving with technology, and you co-evolve like the way of building brains, and like, you know, eventually you're like dissipating energy at a higher rate. And so like, you know, when you zoom out, like the dinosaurs lasted like 300 million years. Like humans as we know them now are gonna have lasted like a million tops, like 100,000 to a million, depending on how you draw the line. And then there's gonna be something very different, you know, 100, 1,000 years from now. And so the question is like, what will that be? Will that be AGI systems only, like digital systems? Will that be human uploads and then evolve? Like, it's really unclear. And by the way, like the Dyson Sphere thing, you know, all of these systems could do like what, you know, I really like Her as a movie because it got so much right, just because of like the path to LLMs and so on. But it ends with this really nice vision of like, oh yeah, the AIs just get really smart and then they like just go do their own thing, and like they don't bother humanity anymore. They probably wouldn't leave like that. In that like they could, you know, downsample and like participate and whatnot. But I do very honestly believe that when you are that intelligent and that capable, you totally can go and build a Dyson swarm around the sun without impacting the planet. And in fact, you would be totally able to devote a small amount of that energy and computing power to helping humanity, as like help your parents sort of thing. And so that path is totally valuable as long as these systems are and end up being deeply ethical in the way that, you know, some of us as a species have been able to be. And so I kind of like hope that we can distill like the best of us and try to like get the models to be the best of us, to kind of end up in that landscape.
Is it in something that also comes up when you think about training the models? Is that, and I think on one of your slides you're talking about, the kind of transform-based architecture is probably here to stay, and so on and so forth. But one reason that the transform,
at least until the systems are able to like upgrade their own stuff, and we have we have automated the tape out of chips. Yeah.
But one reason that these have been successful is out of kind of brute force scaling of, we know these are bad on things that are out of distribution, let's just fit the entire universe in distribution. But there is then a bit of an assumption, which is that the distribution isn't going to drastically change due to
the existence of these things on their own. Yeah, like totally. Yeah, yeah.
So they might kind of it's a kind of it's a kind of war of the world scenario where they kind of arrive and then die off.
Yeah, true. It is possible. It's just like we better not die off along with them if that happens.
Oh.
So yeah, that is the one of like in the universe of like bad, or in the space of all bad things that could happen. These kind of like rogue optimizers that are like quite dumb and so on. Like that kind of thing could happen. I don't know. I think like the improvement rate is just so damn fast. Like that. I do think that we will be in a landscape where we have models that are able to be instantiated in a world environment and able to work out the physics of that space and like do science in that space and are able to like figure out what to do and whatnot. Like 10 years ago, I was like, okay, if you wanted to do a robust test of what an AGI is, like can you just build a physics simulator that gives you like human style, like the transition from classical physics to quantum physics is a very good one to test like the level of intelligence of something, because you have to like totally distrust your intuitions and have to develop a very robust way of telling what's true, and you have to kind of trust the cognitive reasoning. And so that leap, being able to kind of embed the systems into like an environment where they figure out that leap, or they come up with like things like relativity that are just totally unintuitive when you just think about them from like the day-to-day behavior. Like that could be like an interesting test of like, are they able to do this kind of thinking? And I would guess like we're probably close to that. I don't know how far away we are from that.
So I think with the kind of point of transition from classical physics to quantum physics, one interesting historical note is that actually it's very interesting that quantum physics was discovered so late, because all of the mathematical tools that you use for it did exist. What you didn't have was the kind of divergence that people were observing and things that actually motivated
the
trying
bipolar
random
radiation
approaches like quantizing energy, which people just weren't thinking of because you weren't hitting limitations that were just highlighted by experiments. So there's still that strong aspect of being able to interact with the world and do experiments and then adapt and kind of learn from the experiments and not discard them.
Yeah, that's one thing that
and that's quite interesting with all of there's a lot of talk now of like, let's build world models, and you can see a lot of AI companies are now hiring like, let's build world models, let's hire people with expertise in game theory, with expertise in physics, and build all these like huge simulations. But because these are still fundamentally being built on current assumptions, current known facts, because otherwise it would be hard to build a model on unknown facts. I think it'll be quite interesting to see what happens. How do you discover something new in a world model that's kind of fixed?
Yeah, totally. I mean, I think the good thing about games and emergence is that very simple systems of rules can give you fairly complex stuff. And so, yeah, we may not need a too expensive of a simulation to like come up with some like very clever ways of testing that kind of thing. But yeah, the point is a very good one. Like, and I think like a piece of this is intelligence, but another one is like this long-running agency and ability to have this long context window. Like we have like a very long context window. We like remember our lives. We have like also different sizes of context window. We have like the immediate short-term memory of like what's happening in this moment. We have like the recent days, and then we have like years in the past and whatnot. And all of that is like getting compressed into some representation that we can access quite readily. And we have our notion of identity and self and consciousness and whatnot, and like all of this is wrapped together to produce this agent that is able to navigate the world and make decisions and form social relationships and navigate like come up with like good ideas and in a tribe and like all of this kind of stuff. And like we haven't trained any of these models in this direction yet, for a good reason. Like we're terrified of doing that because that's how you get like very intelligent systems that could take over. But I think we're probably in a path where that's going to start to happen by like just unavoidably, or like companies will do it or whatever. And so like that's probably gonna be the next 3 to 5 years. I don't think the next 2, but like it'll start happening.
But it would be interesting to train a model on classical physics entirely, give it, some experimental facts about the ultraviolet divergence, and then see if it comes up with quantization of energy.
Yeah, totally. Yes. And this is an experiment you could run today. Yeah. That'd be great.
So maybe it's one of the AI labs has, run it or something. But it would be, I think it would be like...
Yeah, I think there would be like a high price for doing that. Like I think if you could robustly show that to people, it would definitely convince a lot of the naysayers right now. And so I think AI labs probably have tried that. Or, I don't know if they've tried it, but like, this would be a good price to achieve.
Yeah, I think so. Because even when we develop new series as humans, one of the tests is just disagree with past series, and I don't think we have. We do have things like the DeepMind models which are working on protein folding, and they have a sense of we can discover new proteins and things like this, but they're not necessarily discovering new series, or they're not necessarily validating that what they hint might be correct is actually correct, right? And it's quite hard for me to say or to tell, how far we are away from something like this.
Yep.
And it seems like that's something that will require not a new model architecture or something, but definitely a new kind of way of evaluating models.
That's, by the way, one of the exciting things about crypto. It's like exciting, like a profitable in like a research profitable. Like we can find interesting things, and also kind of risky sort of way, because we're in this intersection of having financial instruments and computable rights and agents and whatnot. We are going to be among the first communities to like, we're already kind of instantiating these agents to like transact and trade with each other and so on. There's a whole zoo of bots all over the place.
With obviously HTTP 4.2 had been around for a long time.
Totally. And so like, this is going to give us a lens into these long-running agents and what happens when they start interacting in societies of some sort. And so this would be like a really cool thing for a bunch of crypto groups to do, is like figure out what kind of economically useful things a society of minds could do, and like then just try and run a bunch of experiments. Now, be careful when you do this and try to like instrument the whole thing so that you understand like what the hell this thing is thinking and doing. You definitely don't want the hive mind suddenly being like, let's take over the world, because that is quite literally how you get rogue optimizers. So, but I do think like our community can do this now, and it's pretty
the let's take over the world thing would be baked into an accurate world model, because if you go and do YC or whatever,
yeah,
that's the kind of pitch.
Yep.
Now, related to this, because we're getting towards the end, I think rather to start talking about industrial revolution, the analogy with that, and what are the bad things from that we should avoid. But obviously, we also actually got quite a lot of good things out of this industrial revolution. And so maybe what are some of the good things? If we look at industrial revolution, large corporations, large governments, which have caused a lot of centralization, and in a lot of sense, the centralization that we've seen in large tech companies has led to the centralization that we're seeing in AI. But maybe what are some of the maybe good things that came out of this that we might see occur again.
Yeah, I'll do like a survey of like what we got out of the Industrial Revolution, and then I'll try to project that out into the future, what we might get out of the new one. I mean, just looking around, like all of the massive production that we're able to do globally of all of the artifacts and things that we can build and whatnot is like a direct consequence of this Industrial Revolution capitalist structure. We have mass sanitation globally, bringing down mortality all over the place, like literacy rates going super high, the end of poverty in tons of places, like the poverty graph is like dramatically lower. I didn't include it here, but I usually have a slide that shows like 9 or 10 different graphs that show just how much life got better for humans globally across a wide variety of domains as a consequence of the scientific revolution and then the industrial revolution of being able to kind of understand biology, being able to understand sanitation, being able to like figure out pharma and like be able to cure people of diseases, like all kinds of stuff, being able to produce food that's good and high quality and so on everywhere, being able to clean water, like just all of the basic stuff that is just so abundant now that we don't think about it. Like you don't think about every day the fact that like you can drink clean water from your house. But like 100 years ago, a lot of people in the world could not do that. And to this day, there are some people that can't because we haven't figured out like the access problem and like the structures. And so, like projecting that forward, I think we can be in a landscape where we can deeply automate production at scale to the point where we have the lower rungs of Maslow's hierarchy completely covered for all humans globally. We do have to figure out the structure, the economic structure by which humans have like the ability to get a right to this. I am kind of stressed by this decoupling of labor and capital that like looms near us. Because that's going to be like a big upheaval in the world. And so we have to come up with some structure by which we can broadly distribute the access to all of this abundance. But we're talking about also these models being able to cure lots of new diseases and synthesize new drugs and like regenerate limbs. Like we're going to be able to figure out how certain animals do it. Like there are literal animals that can regenerate limbs. We know biology can be programmed to do this. We have no idea how to trigger that today. We can figure that path out if we have enough computational capability. And so, like, this is like a super different future that could be incredibly positive for people globally. I'm especially interested in like this digital evolution thing of like being able to scan brains and then upload them and like end unnecessary death that way. People should still be able to die if they want to. Like, you shouldn't take away people's rights from doing that. That seems like a terrible future if like you can't die. But if you don't want to, like, you shouldn't have to, and you should be able to have snapshots and explore the universe and like figure out how to play every single instrument in history and invent like 1,000 more and like have like a full gamut of incredible human experience. Like just think of the vector space of all cool things about your life that you like, and then take that number and multiply it by 1,000,000, and that's like what you could do in like the digital environment, right? And so like, or 1,000,000 here replaced by like infinity if you have enough energy and time. And so like that would be amazing and like a super great way for like all of humanity to spend like the next few centuries or beyond. And like we could have that if we figure out the next 20 to 40 years right. So like let's do that.
Sounds like a good note to end on.
Awesome. Thank you.